Page 33, Rationalizing the Denominator. We're basically multiplying two conjugates together to get the irrational parts to go away in the denominator. Difference of squares and sum of squares are composed with two conjugates. These are conjugates of each other. For a complex conjugate, you just change the sign in front of the I part. For an irrational conjugate, you just change the sign in front of the radical part. Let's look at these examples. So, this first one is done for you. You have 7 all over 3 minus square root 2, and then to get rid of the square root in the denominator, we multiply by the conjugate, 3 plus square root 2. We have to multiply by a unity fraction because anything multiplied by 1 would still be that same number. When you multiply it out, you have 21 plus 7 square root 2 all over 7. Now I know this does reduce. It would reduce to 3 plus square root 2. For these pages, you don't have to simplify the fractions though. For the next one, we're going to multiply each of these terms by 2, and that would give you just 2. If you multiplied it out, we'd have 10 minus 2 square root 3. And if you multiply these together, you can use your difference of squares formula. It would be 5 squared minus square root 3 squared. So that's going to be 25 minus 3. That's 22. And again, we could have written this in reduced form as 5 minus square root 3 over 11. But having it like this is fine for this page. Alright, if we look at the next one, we have 1 over 4 plus square root 10. And it equals something with the 6 in the denominator. We want to find the conjugate. Remember, you just change the sign of the square root part. So we're going to have 4 minus square root 10. 4 minus square root 10. And the numerator, 1 times these numbers is the same thing. 4 minus square root 10. Let's look at a few more examples on this page. Let's look at this one. So we have 3 all over square root 7 minus 1. The conjugate would be negative square root 7 minus 1. Negative square root 7 minus 1. If we multiply this out, we get negative 3 minus 3 square root 7 all over negative 6. So we basically have 7 minus 1 times 1, which is 1. And then there's a negative right there. So we just have negative 6 there. If you don't remember that formula, you can also use the box or FOIL method for the denominators. Let's look at this one. 5 all over negative 2i plus 7x. The complex conjugate would be 2i plus 7x. Multiplied by the unity fraction. And then you would get 10i plus 35x all over 4x squared, or not 4x squared, 49x squared plus 4. And that would be your rationalized fraction here. Okay, let's look at the last row of fractions. So this column right here, we're trying to fill in the first fraction. In the second column, we're filling in the last fraction. And then for the last column, we're finding the complex conjugates and finding a new numerator. So for this one right here, the complex conjugate of negative I plus 1 would just be I plus 1. Change the sign of that one. Now, to get from here to here, it looks like we multiplied by a 2. 2 times negative I is negative 2I. 2 times 1 is 2. So that's what we would put here. And again, you could simplify this down to 1 minus I over 1. And then if we look at this one, we have 5 squared plus 3 squared. That's 25 plus 9. That's 34. So we have 34 in the denominator, and then we distribute the 4 to each of those to get 20 minus 12I. And then for this one, the complex conjugate of 9 minus I is 9 plus I. So we multiply numerator and denominator by 9 plus I because we want to multiply by that unity fraction. Distribute the negative 2, you get negative 18 minus 2I. Finish the rest of this page, check your work, and then move on to the next page. Page 34. At the top we have y over the nth root of x. The conjugate of the nth root of x would be the nth root of x to the n minus 1 power. If you multiply those together, you'll get an x in the denominator. You could also do this for any value of x to some m power. So the conjugate of this would be the nth root of x to the n minus m. So these are conjugates, where we multiply them together, they just give you x. Let's look at some of these. So, we want to multiply 1 times the 4th root of 5x to the 3rd power, and that just gives you the 4th root of 5x to the 3rd power. We multiply the conjugates together, you get 5x left over. This is an even root, so we're going to put absolute value signs on the outside of it. For absolute value signs, you put them if it has an even root and if the variable has an odd exponent. Okay, let's look at the next one. So the conjugate of the 5th root of 7x would be the 5th root of 7x to the n minus 1, which would be 5 minus 1, 4th power. So 5th root of 7x to the 4th power. So if you multiply those together, it gives you 7x. Multiply the 3, and you just have 3 times the 5th root of 7x to the 4th power. You could also multiply out the 7 to the 4th and x to the 4th, but we could just leave it like this for this worksheet. Let's look at one more on this page. Right here we should have a 4, so go ahead and change that on your paper. So the number that would go at the top right here is just 1. And then the number in the denominator, we'd have the cube root of 4x squared. So finish up this page and then move on to the next page. Page 35. Now we have, instead of square roots, we're going to have cube roots. So we'll use the sum and difference of cubes formulas to conjugate these. Recall from your factory unit that a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. If we look at the first example here, it's all done for us. So we have 5 and then times our conjugates, and then it would give you the fraction with the rationalized denominator. So we have 2 plus the cube root of 7. So we have a plus number, so we identify A is 2, and then B is 7. And then you just plug it into this formula right here. So a squared would be 2 times 2, that's 4, minus 2 times the cube root of 7, and then you would add the cube root of b squared. Well, 7 times 7 is 49, cube root of 49, and then you end up with a cubed plus b. So it'd be 2 times 2 times 2 plus 7. That's 8 plus 7. That's how they got 15. On the next one, see if you can identify A and B and see how they got this one. They'll use the difference of cubes to find that one. Let's look at the next one. So we have blanks and then we have the conjugates. So it looks like from looking at this, we have A is going to equal X and B is going to equal 2. So there's B and then there's A. Square root of X squared is just X. So we would then have a minus sign, so we're going to use this first one. A plus the cube root of B. So that would be X plus the cube root of 2. And then at the top, it looks like nothing changed, so we're just going to have a 1 up there. Pause the video and try this one. See if you can find what these two expressions are. Let's look at the next ones. So for this one, we're just multiplying this out and finding the products. So x times 1 is x. X times cube root of 6 with a minus in front of it is a minus x cube root of 6. And the x times cube root of 36 is going to be plus x times cube root of 36. Okay, so now we have A is 1 and B is 6. So A cubed plus B would be 1 plus 6, and that's 7. Okay, pause the video, try this next one. Alright, let's look at the next example here. We have 9 times something over 4 plus the cube root of 8 times that same something. So we have A is 4, B is 8. Right here, we're using our sum of cubes formula. So we look back at the top, and we're going to do this. A squared minus A times the cube root of B plus the cube root of B squared. So a squared would be 4 times 4. 4 times 4 is 16. Then we have minus a, which is 4, times the cube root of b, which is 8. And then plus the cube root of b squared. 8 times 8 is 64. So that is our conjugate. So we have 16 minus 4 times the cube root of 8 plus the cube root of 64. Now we just multiplied 9 times each of those to get our final numerator. If we multiply those out, we get 144 minus 36 times the cube root of 8 plus 9 times the cube root of 64. We could reduce the cube root of 64 to give you a 4, but you could just leave it this way for this worksheet. Okay, go ahead, try the last one on this page, check your work, and then move on to the next section.